Hi there. All right, let's start doing section 7.4. Section 7.4 discusses the use of counting techniques in probability. So all of those combinations, permutations, multiplication principle, what we're now going to do is just relate them to probability. Okay? All right, so let me start out by taking an example here. Suppose there are, say, 19 people in a club, and 3 are to be selected. I don't know, to do something. Let's just leave it ambiguous here. All right. My first question is, in how many ways can this be done? All right, so whenever you're asked in how many ways can something be done, the first question you need to ask yourself is, does order matter? And I claim in this situation, order does not matter. And one of the things that you're going to find actually is in the majority of our situations, order tends not to matter. All right, since order doesn't matter, we know that we're dealing with a combination. So we can say, well, there's 19 people and we want to choose 3. All right then. Now let me say this. If Sue is one of the club members, I want to know in how many ways can the 3 people be selected if Sue must be one of them? Okay, still no probability. I'm just asking in how many ways. All right, well, again, we still have 19 people. The only stipulation here is of the 3 selected, we really want Sue to be one of them. So, I think you'll grant me that there's one Sue, or let's assume there's one Sue, and we want to choose her. Okay? Well, we have one of the 3 selected. We need to select 2 more. Well, we've already taken care of Sue, so if there's 19 people in the club, and we've already talked about Sue, I think you'll grant me that there's 18 people left to choose from, and we want to choose 2. Now, technically you don't need this first term. You could just say, hey, there's one way to choose Sue, choose her, and then, well, there's 18 people left, and we want to choose 2 of them. Okay? All right, so this kind of goes back to the section 6.4 that we were talking about prior. Now, let me ask you this. What is the probability that Sue is one of the 3 selected? Okay, now this goes back to something that, remember, the probability of an event is the number of elements in that event, in other words, the number of ways it can happen, divided by the total number of ways that the 3 people can be selected. Okay? Well, aside from actually having concrete numbers and having computed this, well, in how many ways can my group of 3 be chosen if Sue is one of them? We saw that was 1 choose 1 times 18 choose 2. And then we divided by the total number of ways that 3 people can be selected. So then we divide it by 19, choose 3. Okay, so this is the new idea that's going on in here. One of the key things to pay attention to is you need to make a distinction between in how many ways versus find the probability. Because when you find the probability here, you're going to have to divide. All right, so that is one type of example. What I would like to do now is take another example, and then we're just going to play around with it quite a bit. All right, so how about this? Let's be boring and let's just say we have some club again, okay? So let's suppose a club consists of, I don't know, how about 12 women and 7 men. A delegation of 4 is to be selected. Okay, part A. In how many ways can this be done? All right, well, how many people are in our club? I think you'll grant me 12 and 7 is 19. And how many people do we want to choose? We want to choose 4. Notice this is a combination because the order doesn't matter. I must like the number 19 today. Okay, so next, let me ask you this. In how many ways can the delegation be selected if it is to consist of exactly 2 women and 2 men? Okay, well, how many women do we have to choose from? We have 12, and we want to choose 2. Remember, and means multiply. So, and 2 men, so times 7, choose 2. All right, now let's find the probability of the statement in B. I'm getting lazy. In other words, we want to find the probability that the delegation consists of exactly 2 women and exactly 2 men. Well, in how many ways can we choose exactly 2 women and exactly 2 men? We just did that. 12 choose 2 times 7 choose 2. And in how many ways total can we pick our delegation of 4? 19 choose 4. Now, one thing that I want to mention in terms of just a basic check mechanism here is notice my top numbers here add up to my top number, and my bottom numbers add up to my bottom number. That's pretty crucial, okay? It's a good thing to keep in mind. All right, well, now let's find the probability the delegation consists of at most 1 man. All right, what does at most 1 mean? I claim it means 0 or 1, okay? So we're interested in either 0 men or 1 man in our delegation. Now remember, throughout this whole example, we're picking a delegation of 4. So I think you'll grant me if there's no men on my delegation, that must mean that all 4 are women. Additionally, if there's 1 man in the delegation, then 3 of the members will be women. All right, so I'm going to repeat this again. And means multiply, or means add. Let's do it. 0 men and 4 women. Well, 7 choose 0 times 12 choose 4. Or tells me plus 7 choose 1 times 12 choose 3. And again, we're finding the probability, so we need to divide it by the number of ways we choose our delegation. Now, one quick comment again about the check mechanism. Things in mathematics separated by plus or minus signs are called terms. So I claim we have 2 terms in our numerator here. And again, notice in each of my terms, the top numbers add up to my top number here, and my bottom numbers add up to my bottom number there. Okay? So let's just do one more. How about we find the probability that the delegation consists of, oh, who cares, at least 3 men. Well, at least means 3 or more, so 3 men or 4 men. Why do we stop at 4? Because that's how many people are in our delegation. Okay, if there's 3 men in our delegation, I think you'll grant me that there's going to be 1 woman. If there's 4 men, there's no women. All right, and how many ways can we pick 3 men and 1 woman? Well, 7 choose 3 times 12 choose 1. Or tells me plus 4 men and 0 women, 7 choose 4 times 12 choose 0. And again, we divide that by 19 choose 4. Now, technically speaking, you don't need something choose 0 because there's only one way to choose none of them, just by not choosing them. However, I always write that term when I'm explaining these things, again, so you can notice again that the top numbers add up to the top number and the bottom numbers add up to the bottom number. Okay, so let's just do one more example here, and then that'll be, or maybe 2 more examples, but then that'll be section 7.4. Okay, so suppose a researcher gathers, I don't know, 6 wheat plants, 4 barley plants, and 2 rye plants. Okay, and to do some sort of experiment, she selects 3 plants at random. Okay, part A. In how many ways can this be done? Well, how many plants are there? You add these up. There's 12 plants, and we want to choose 3. All right. Now, let's find the probability that the sample contains exactly 2 wheat plants. All right, well, this is a situation where you need to be a little bit careful. She's selecting 3 plants. She wants exactly 2 wheat plants. And since my sample consists of 3 plants, 1 other plant. Notice, we did not specify whether it's barley or rye. The only thing we know is it cannot be wheat. Okay? So throughout this whole problem, we're going to be dividing by 12, choose 3. We have 6 wheat plants and we want to choose 2. How many other plants do we have? Well, if there's 4 barley and 2 rye, we have 6 other plants and we want to choose 1. Okay, so what if now I want us to find the probability the sample consists of, how about exactly 2 wheat plants and 1 barley plant. So now we've actually specified where that third plant is going to come from. So this is going to look a bit different. Again, we have 12 plants and we're choosing 3. And again, we have 6 wheat plants and we're choosing 2. We have 4 barley plants and we're choosing 1. Now, in order to satisfy that check mechanism, you could say, well, we've got 2 rye plants and we're not choosing any. All right? So, one more question pertaining to this. Now let's find the probability that the sample contains at least, well, let's be silly, 2 rye plants. All right, at least 2 means 2 or more. Okay, now, in the context of this problem, we're picking 3. So what this says on first glance is we want 2 rye plants or 3 rye plants. But wait a minute, can we have 3 rye plants in our sample? Absolutely not, because we only have a maximum of 2 to begin with. So, moral of this story, read carefully. So the only way my sample can consist of at least 2 rye plants happens to be if it contains exactly 2 rye plants, and therefore 1 other. So we have 2 rye plants, we're choosing 2, and I claim we have 10 other plants, and we'll choose 1. All right, so that concludes section 7.4. Thanks.